Good afternoon, everyone. How are you doing today? I heard like the beginnings of applause, like in the crowd. Cool. I'm going to try that again. Good afternoon, everyone. How are we doing today? Yeah. Okay, cool. How many of you are visiting Galvanize for the first or maybe second time? Just real quick. Cool. Well, it's nice. Welcome to all of our guests. For those of you who don't know who I am, my name is Jenny Engard. I am the Student Success Manager for Galvanize. So basically, it's my job to shepherd these amazing folks that you're about to see through the program and make sure that they have all the things that they need and kind of like make sure that everything runs smoothly behind the scenes here. That being said, welcome to Galvanize. For those of you who are guests of Galvanize, Galvanize is a dynamic learning community for technology. So basically, we empower people to change the world through tech. And we welcome everybody, and we try to be a very, very inclusive, dynamic community. For those of you who may be interested in our data science programs, I want to introduce you over to Amara. You might have spoken to her earlier, but if you have any questions about, oh, there's Amara in the back. Feel free to wave to her if you are interested in learning more about applying to Galvanize. She's here to help you out. I am so excited to present these people that you're about to see today. They have been working their butts off, frankly, for the past 3 months on the capstone presentations that you're about to see, and they have spent the last 2 weeks preparing what you're about to see today. Also here today, I want to introduce you to our Partner Relations Manager, Kara. Kara is going to introduce our panelists and say a few words as well.
Thank you. So my name is Kara. I'm the Partner Relations Manager here, meaning I work on the careers team and manage industry relations. Part of what I get to do is also bring amazing panelists to join us for this event to really enhance and create an interactive dialogue part of the presentations, which I think is actually really, really important. So that being said, I would like to pass along this mic and have each person introduce themselves briefly.
Hey everybody, I'm Nick Gaylord. I'm a senior data scientist at Change Healthcare, which is basically the company that operates the payments network for the U.S. healthcare system. So lots of very big, large-scale, sensitive data-related challenges there. I've also got experience in the past doing more product-style data science and some smaller startups here in the city and other stuff that I'm happy to talk to you more about if you're curious.
Hi, I'm Vin Vashisha. I've got a very small company called B Squared that is basically will take cash from everyone's stage right now. Trying to do data science and machine learning consulting. I've been in tech for a little over 20 years, I think so. Got into data science about 10 years ago and started to actually be called data science. We have the tools and tools that we do now. And love it. Absolutely passionate about it. So that's about all.
Hi everyone, I'm Jenny Romanek and I manage the data science team for ads and business platform at Instagram. Really excited to hear from all of you. We are hiring currently for a bunch of different product data science roles, both in my org and at the rest of Instagram. So come talk to me afterwards if you're interested.
Hello everyone, my name is Manas Kardas. I have a background in network analysis and specifically semantic networks and text analysis. And right now I'm working for a company called Ticketfly. And we do event management for big and small venues. And we are also hiring, and recently Ticketfly got acquired by Eventbrite. So hopefully I'll be moving to Eventbrite, and so exciting things forward. And we do a lot of work in recommendations and basically event discovery so that we don't want any seat to go empty on the show. So yeah, that's it for me.
Thank you so much. And now I'm going to welcome up Darren to kind of give a little snapshot into this class.
All right, thank you. So, good afternoon, everybody. Today is not only capstone presentations, it's also a celebration because our students now are basically done. Starting tomorrow, they're on the job market. They're going to put everything that they've learned throughout this course, everything they've learned from these projects, to eventually join the workforce as data scientists. So they're excited to share this with you because it's literally everything they've done for the last 2.5 weeks. They've been eating, sleeping, and breathing this particular project. And the way they choose the projects might be partnering with a company. It might be choosing something they're passionate about. But mostly they're just excited to share with you all the work they've done. Data science is basically taking noise and turning it into value. When you have hundreds of thousands of rows and thousands of columns, all you have is numbers until you actually analyze that and turn it into value. So that's what they've been doing. They've been working on taking all of this data. And they're going to tell you something about that that maybe no one's actually seen before until we've analyzed it. And that's pretty cool. It's also a celebration for them because now, once they're finished with this particular presentation, their time at Galvanize for learning is basically done. We're going to help them get ready for interviews, but this is the end for them. It's a culmination, it's a celebration. So please join me in welcoming our first person, Ernest.
Hi, I'm Ernest Picado, and today I'll be introducing to you my Twitch emote recommender. If you're not familiar with Twitch, it's essentially a live video streaming platform where you can watch people play video games. And today we'll be discussing how viewers interact through the chat. So why subscribe to a channel to begin with? Well, emojis, emoticons, emotes, whatever you want to call them, they can convey emotion or entire sentences in just a single image. Chat, that is very valuable because it can move very quickly at times. And that helps, I guess, in the communication. And so, by subscribing to a channel on a monthly basis, you can then gain access to a set of exclusive and unique emotes that you can then use throughout any other Twitch channel. Currently, Twitch has a discovery directory that recommends channels based on your viewing history. It does a pretty good job. But what if we can make a more serendipitous recommender that works on the basis that people want to be surprised by the unexpected? And so, based solely on the emotes, can I make a connection between the channel on the left to the channel on the right? And that's really the basis of my project. So, how did I get my data? I made calls to a third-party API and got channel IDs, and then made requests to the Twitch API to get additional information. As you can see, the distribution of the number of emotes per channel is right skewed. Then, I had to parse the emotes for each channel. And for 2% of the channels, I actually had to manually parse them. But in the end, the most common emotes were hype, love, and rage. I moved on to vectorize my emotes with TF-IDF and applying cosine similarity. I also looked into applying LDA and including the distance, but in the end, I only moved on with the first model to complete the project. From there, I had to decide how do I actually validate my recommendations. And for that, you really have to go to what the goal of the recommender was, and also make serendipitous recommendations. In order to really measure that, you have to go to the end user and see what they think of the actual recommendations. And to do that, I made a web app using Flask and deployed on Roku. Here's just the homepage of my app. And here, if you have a Twitch channel in mind, you can see who has similar emotes to them, or see who I recommended them to, or also try something new. And so for instance, say I really like this implementation of the thinking emote and want to expand my collection of thinking. Well, my recommender included 5 of the channels, 3 shown here, the 4th, and the 5th. All these channels exposed to me that included the emote that I was most interested in. But in that same instance, I was exposed to their other emotes that may or may not expand my emote vocabulary or the way I can express myself in other Twitch channels. And so while this is indeed a cherry-picked example to show the potential of my recommender, in the end, I'd like to get this in the hands of even more viewers and even implement my second model to see how that changes the recommendations, if at all. Thank you for your time. I'm Ernest Picado, and here are my links. Any questions?
Hi, thank you. How did you decide to stop trying to implement both models, and when you did that, how did you decide which one to pursue?
That's a great question. First off, the main reason why I looked into LDA and trying to apply that on the model is because I didn't really know how to validate, right? That's one of the hardest things to do with unsupervised learning is trying to find a way how to validate. And so the main reason why I looked into LDA was to, I guess, work in a way to reduce the dimensions in some way so that when I can validate, I can then apply that, what the findings of that was, and then in a supervised manner, get a different metric to validate in that sense. But then it really had to go back to what the goal was, right? And that's making a serendipitous recommender. Really, you can't really measure that with a metric, really. You have to go to the users and see what they think. And that's why I chose to just proceed with the first one, because it is a 2-week project. And so I really wanted to just continue on, make a decision, and try to get my web app out there, since that was one of the deliverables that I chose to pursue.
So I'm not sure if you mentioned it, but did you have any kind of accuracy measurement for the models?
Excuse me?
Did you have any accuracy measurement
No.
metrics?
No, I did not. That's what the app is meant for, is more like, okay, I introduce these recommendations to the users, and then I haven't developed the actual framework for how I ask whether or not it was serendipitous or whether or not it was helpful, but that would be the purpose of the web app, is to validate that.
So, are you getting any data from the web app?
Not currently.
Thank you for this.
Thank you very much.
All right, so my name is Daniel Lund, and for my project, I chose to focus more on kind of the data engineering side. I had a lot of interest in big data and kind of those things, so I wanted to kind of learn from that. The data set I chose to use was the Common Crawl data set. If you're not familiar with Common Crawl, it's basically a photocopy or a web copy of the internet. And so what that does is produces 3 files, and the one that I really was concerned with was this .wat file. That's the metadata on these websites. And this data is publicly hosted on S3. And then specifically, I chose to focus on a subset of that, which was the news data set. And that is different in that it's crawled every day, and there's 4 crawls per day, which yield about 1 gigabyte of data per crawl. What happens is then these are 1 gigabyte files, and then again, these are all hosted on S3 independent of the other. For my project, I chose to build an automated data pipeline with this metadata, and one of the biggest challenges in using the news data set was that the file I was concerned with, .wat, which contains the metadata, is not actually available. And so that was one of the biggest challenges, was how to convert that, and I ended up using a converter and was able to get the files that I wanted. What I ended up getting out after writing my data extractor was an author, a date, a title, a top URL, an article URL, keywords, and is media outlet, which actually will tell you whether or not it's a photo or video outlet. I ended up with about 300,000 articles per month, and daily with this automated pipeline, I get 10,000 articles per day. So why article metadata? I chose to build a distributed system graph with it. I wanted to see what top-level domains were important, what categories, what dates, and this way I chose to use graph frames, which is a Spark library that is used to build graphs out of distributed systems. What I drove me for this was the Common Crawl blog. Actually, there's a lot of people are asking for this metadata, and people are trying to see what's coming out in news outlets. So I chose to try and find what properties of the graph exist in these. So my results, I actually parsed 600 gigabytes of Common Crawl files that were converted and then downloaded to CSVs. And the important thing is here, the CSV is a lot smaller that I've built, so it's actually very attainable for quick projects and things like that. So from going to 600 gigabytes, we bring it down to just the metadata. And then this way you can actually, with the article URL, you can find out more about those articles and things like that. I also used a combination, just from the .wat files, there's a lot of missing data just because of how websites don't necessarily follow all the same protocol. So I combined that with a newspaper library for Python, and actually yielded a lot higher percentage. I got about 55% in the three most important categories that I wanted to graph, which was author, date published, and category. This category one is able to track the categories through articles. In total, I had about 1.5 million articles that were in my Spark graph and found some interesting stuff. So this is actually just a subsection. This is just the June 2017. But this Reuters.com is actually a really, obviously, powerful website. It's actually a website I had never heard of until this project, and I actually have now started reading from it. And it's got, it pulled 55,000 articles, and 1,700 unique authors, and 80,000 unique keywords. For future work, I'd like to change the graph structure. I'd like to go more into OrientDB. The biggest problem with graph frames is that you have to build it all at once. And so I'd like to be able to put it more into a relational database kind of structure, so that way I can just add articles as they come in. I'd also like to use Hadoop for the converter and the metadata extraction. Again, part of the biggest problem was that those metadata files were not there. So being able to distribute that and speed that process up would be great. I'd also like to add support for more languages, and then also build a web app, which is for an article recommendation system. And I have most of that done. It's just waiting to get put up. So with that, my name is Daniel Lund. I'd love to take questions, and thank you so much for listening to my presentation.
Hi, so thanks. This was an interesting insight, especially into your methodology. But yeah, I'd love to hear a little bit more about the motivations for this work. You know, what questions were you hoping to answer by doing this, or what type of functionality were you hoping to enable with the end result of this?
Yes, so my motivations were actually really behind just as far as the data engineering, but also I think our news articles that are pulled daily is a really interesting thing. And having just very easily accessible data like URLs, I would like to be able to run like topic analysis and all those things kind of in the more data science now that I have the data very easily available and being pulled every day. That was kind of the motivation, but also just the ability to work in that distributed systems and work more on kind of a large scale data set.
So can you describe your graph? Is each node a news article, or what is it?
Yeah, so this is actually the nodes. I chose to do three pieces. A news article is a node, a unique category, and then also the top level domain. So I wanted to kind of see, I would eventually like to include the links to the top level domains and be able to kind of traverse like the shortest path from article to top level domain. But again, given the time constraints, I really wanted to just kind of see what top level domains are really interacting with articles and categories.
So is this live in any way, or did you just run it once and now you have the 1.5 million?
So the metadata is actually being pulled daily. So the Common Crawl does this every day. They do about 4 news article crawls. And so that is being automated to check every day which articles have been, which of these files have been added. And then the CSV files that I produce actually are under the same naming convention, so you can just go back and check where those came from as well. But that is being done streamlined pipeline as we speak.
So what did you use to do that, and how much time did it take you to convert a WAR file to a CSV?
So from the work to the 2 different files was one of the biggest choke points, and that was about, per file, that was about 10 minutes. Metadata extractor, it's being I/O bound, so the newspaper library is trying to fill in missing data. That's about 5 minutes for the daily individual file, and that yields about 10,000 articles. Again, part of the biggest problem was just, A, it's I/O bound, but then also the fact that some of the languages aren't supported in a few of the writing outs that I chose. So I'd like to add more, and then I'm hoping to get more articles. Thank you, Dan.
I'm Drew Erickson. I spend a lot of time thinking about issues in human biology and human health. So when it came time for my project, I jumped at the chance to work on a problem in the space with some cutting edge tools. So medical imaging is a critical component of diagnosis, the amount of it is growing all the time. 2015, a study from the Mayo Clinic noticed that although specialists take several minutes per image to do their analysis, at the rate of their data generation, it would take them 3 seconds per image to keep up. So how can we do this faster? My approach to this was to look at data from the University of Pennsylvania School of Medicine. So these are MRI scans of people with glioblastomas. Here I've taken 2D images from three-dimensional image from each of the planes, labeled with 3 kinds of tissue types. Here we see the edema. This is the swollen tissue between the brain and the tumor, the actively growing cancer cells, and the necrotic dying cancer cells at the core. Altogether, I have 88 high-quality MRI scans and 70 that are low quality. And I took a 2D image from each of the planes, and altogether, I'm looking at 4 billion voxels that I'm trying to identify as one of these 3 kinds of tissues. To approach this problem, I use a convolutional neural net. So this has an advantage that it can featurize information across that are involved in spatial relationships. So here I'm going to take these images that are from the different planes, from the MRI scans, and I'm going to put them into the model, and what I will get out is a prediction for each of the voxels in the image. Additionally, I tested a model with dropout. This is a newer technique for use in neural networks. It's a type of regularization. So first I tested these 2 models with the high quality data. Here we see the actual 3 different types of tissues. And here laid on top, we see what actually we get out from the model. So this performance is good. It's very similar to other types of convolutional neural nets. And now comparing this with the dropout, again, we see the actual and then the prediction. The precision on the network with dropout was higher. It was lower, and this led to an overall F1 score that was slightly lower than the other model. So moving on with the model without dropout to the larger data set, we find that we're still getting qualitatively pretty good coverage. The numbers here are slightly lower, but again, performance is within range of other convolutional neural networks. We step back and we think about this problem just in terms of overall tumor identification, and we collapse all these tissue types. We find we actually can get excellent performance out of this model. So overall, when I run this prediction on my laptop, I can get a prediction in about 7 seconds per image. So we're getting a lot closer to that speed that we need. And I think what will be an interesting next step for this will be to think about what else do we need to know about how to come out of these kinds of imaging. For example, the overall survival of the patient. And I think that's something that these networks could also generate at the same time. So that's where my project stands right now. Thank you, and I'll take the questions.
I have a question.
Yes.
Were all of the tumor regions connected, or were they disconnected?
Yes, this was a single glioblastoma. Yeah. So the sections, the X, Y, and Z plane sections were all of the same, just from different directions. Yeah.
Yeah. How did you calculate the accuracy in there? Did you like by area overlap? How did you calculate?
So you were asking about how does accuracy calculated?
Right. Thanks.
Well, I didn't use accuracy because it's not a very good metric in this case. It's kind of an imbalance. So we're actually using precision and recall here.
I guess my question is about, are you looking at the area overlap with prediction versus the actual tumor? How does it make you know if you're highlighting the right area?
Comparing to the actual data that comes from the study. So these data were labeled by radiologists who actually sat down and looked at these images and marked each voxel as one of those 3 tissue types.
Okay, so this is voxel by voxel evaluation.
That's right.
Okay, so not like, I mean, did you consider any sort of like intersection over union type of evaluation for just, getting a sense of the quality of your aerial coverage and your predictions or anything like that?
intersection of union of the, are you thinking about in terms of patch-wise or?
Yeah, I mean, like in computer vision, oftentimes when you're doing, sort of scene segmentation or things like that, one of the challenges is sort of how accurately are you bounding a given region with a given prediction for what it contains, right? Mm-hmm. And so, I mean, I think voxel by voxel is a perfectly interesting way of thinking about it. I was just wondering if you considered any other evaluation metrics besides that.
Yeah, I did look at some other studies where they'd actually done some patch-wise stuff at like 30 by 30 voxel patches, that sort of thing. I just decided to go with this approach instead. So the performance of those networks are, on some problems, can be equivalent approach.
You can ask your question first.
Yeah. These things are fairly small. How do you clarify that you're not memorizing?
So there were 150 patients, and that ends up with about 474 slices from each, and then overall about 4 billion voxels. So the actual variance that's going into the model is still very high. We're looking at different slices through, although it's the same brain, we're actually looking at totally different data for each slice.
I guess what I'm asking is like, so 30 features of that specification that are kind of basically learning.
Yeah, I mean, I think that is a concern. I mean, obviously, if it's not it's necessarily like the spatial dimensional features, but maybe there are issues with the data collection. There's some similarity there. So, I mean, I think that is an open concern. I mean, expanding into the larger data set, potentially kind of offsets that a little bit. But yeah, I think so.
Oh, there's another data set.
Well, so I sort of separated the data into high quality and low quality. So there's.
That's okay. My question was zooming out a little bit. So you showed that ultimately you were able to achieve pretty high precision and recall with your model. You described this in terms of a medical problem. There's more data for radiologists to review than they possibly can do in a time-efficient manner.
Right.
If you were to implement a model like this at scale, how would you deal with the fact that you're still going to miss quite a bit? I think I forget what the exact number was, like 0.87 or something. How do you consider sort of like implementation or productizing of this in terms of that challenge?
Yeah, so I guess when you think about the issue at hand, sort of question is, what kind of error are we willing to tolerate? And obviously, I think when we're dealing with cancer cells, so there's a concern that you want to make sure that your false negative is almost zero for the cancer cell. So I think, but again, we're sort of looking at three different regions of tissue. So I think that with a little bit more domain knowledge, I would probably have some understanding of that edemic tissue. Is there an expectation that should be resected as well as the actual active cancer cells? And I think that would inform, how we would want to actually do the model.
Thank you, Drew.
Hello, my name is Mario, and I'm here to tell you a little bit about this HR research paper recommender that I built. I work with this division of Deloitte called Immersive. What they do is they produce research for HR professionals. Essentially, they go to their site and if they have a question about hiring, retention, training, all these different HR subjects, they'll find it there. There's about 3,000 documents, research documents they can search through. There's about 45,000 registered users, and the big challenge is how do you find the right documents for each person? Waiting through 3,000 documents is a little bit difficult. Right now, they're not doing a very good job with it. They're simply just giving them the most recent content. So they want a good recommending system. They want to be able to help them find what they want, to introduce them to a variety of research, and to thereby increase activity, retention, and renewals. So my goal then is say, okay, I'm going to take their user activity and their preferences, and I'm going to build a recommending system that takes those elements into account. So I was provided about 10 years of download data and favorite data and content metadata for all their users. And naturally, the natural metric to figure out what people like is obviously what they favorite. However, only about 3% of all their users actually favorited anything, at least one at least one document, much less multiple documents, so that I could get a signal out of it. So what I instead focused on was an implicit signal of essentially when they download, this is what they like. So I took the download data, which is about half of them, the downloaded documents, and that's why my target asked what they like. So I will focus on the download history. To give you a scope of the challenges of this problem, right here I have a histogram of the downloads per user on the left, well, the right. And this, as you can see, there's a really big peak at the very end, essentially saying that most people downloaded like one or two, very few documents. Essentially, they're very casual readers. They go, they find what they need, and they go away. When you essentially go back to the higher downloads, you see the power users, people who just download all the time or really look into this stuff, and that's where you find signal. That's where you find really a lot of activity. So I will focus on these power users. I will essentially classify the other people as more sort of the casual and into a cold start case, and then we'll focus my recommender on the people who give me signal how they use this system. So the way I do this, I use collaborative filter. I want to essentially I create a matrix of users and items or documents, and every time someone downloads a document, there's a 1. There goes a 1 in the piece of matrix. There's a 0 otherwise. It's a very sparse matrix. Calculate the similarities between all these items. Essentially, if the same people download these items, these documents, they're very similar. So I create a similarity matrix where it essentially just tells you how similar every item is to each other. And then from there, I rank them for each item. I say, for item 1, you sort them all from more similar to the other one. And for each item that I create, essentially a group, a little neighborhood, with a predetermined parameter n, tells you these are the n most similar items to this item. So I create these neighborhoods, and then I start my recommender, and I say, okay, get a user, and I ask, is this a power user or not? If it's not a power user, it goes to the cold start case. If it's a power user, then I say, okay, take all the items that this user has downloaded, compare them to all these neighborhoods that I created, and then rank those neighborhoods. So now I create another level of similarity, another layer of it, and so now I have a ranking of all the neighborhoods that I created. And then from there, I'm going to start recommending from those bins. And from there, I ask another question. I say, well, should we recommend depth or should we recommend breadth? Do they want to go deep? If we don't want to recommend breadth, then I recommend only along that top neighborhood that they ranked. Simply documents along that neighborhood. If we want to give them a breadth of recommendations, I recommend the top from the first neighborhood, then I move to the next one, give them the top, and then to the next one, and so forth. And then I create a set of recommendations at the end that the recommender returns. So as you can see, there's a number of parameters. There's the size of that neighborhood n, there's whether I want to put breadth or not recommendations, and how big of the set of research documents do I want to recommend. So I want to explore that. Now, how do I validate this? How do I validate what I'm doing here? This is a big question for recommenders. It's a big problem, especially in this case, of using the collaborative filtering. I want to basically tracking the usage of all the users. If I take up a chunk of that, I lose a lot of the power of the recommender. So the way to validate this is to essentially pick a user, pick an item at random that they downloaded, take it out, recommend for that user, and then check whether that item that I took out is in the set that I recommend. So that's my accuracy, that's my target. Here's a plot of the accuracy that I just described versus the number of recommended documents that I'm saying that I'm giving. And of course, it goes up as I recommend more and more. But what's interesting here is that this is a plot for different parameters. The solid lines are what I recommend widely, with a breadth of recommendations. And the dashed lines is what I recommend deeply, when I don't simply just recommend in a narrow sense. So essentially what I'm seeing is that my accuracy improves when I recommend in a wide way, with a breadth of recommendations, which is a really good insight that my recommender has discovered about the usage of the site comparison. So my plan is to fine-tune this recommender to give a good set of recommendations initially, and then from there, from the set that I create, narrow it down with further machine learning that incorporates the user's preferences and the content editing. So including the big finding that I found was very fascinating is that these users like a breadth of recommendations. I'll present them an A/B testing framework so they can test the recommender to what they're currently using. There will be, I'll also give some recommendations in data cleaning and management. This is very old data, it needed a lot of work. And in the future, it needs a little bit more feature engineering while that's cleaned up. Some clustering of items and users to reduce the dimensionality of the problem. And some more sophisticated techniques once I get that initial recommendation to further narrow it down to a really nice small set that they would like. And some more interesting features about trends and time effect on this data. My name is Mario, and that was my presentation. Thank you very much.
All right, so I guess two-part question. Part one, speculate as to why you think people prefer breadth over depth in the recommendations. And part two, do you really think it's the case that everybody does, or are there multiple different types of site usage strategies or user segments that might respond to recommendations that are structured differently? And do you have any of those?
That's a great question. It's a very in-depth question. I've been thinking about this a lot. What exactly does this mean? At first pass, the idea is, first of all, we have to look at the audience, right? I didn't tell you much about the audience. I don't have much time to do it. But the people who read this research, they're not like researchers. They're professionals who have questions that come up. They're in charge of a department, or they're executives, or they have specific problems. And they come in and say, I have this question, how do I answer it? So they'll have a variety of questions in the daily job. So they'll look for a variety of topics. That's my best interpretation of why they're going to breadth of content, of documents. Do I think all of them are like that? I don't think so. Again, I still have to look deeply at the profiles of the users, but there's a variety of them. I'm hoping that once I get to the feature engineering, I can start clustering users by their position. I have information on their job position, their job interests, and I would expect to see different behavior from that. Absolutely, that'd be really fascinating to see.
How would you handle cold start?
How do I handle cold start? That's really, really difficult. Right now, since I focus mostly on creating the recommender for the power users, what I'm doing right now is simply taking their chosen subject, they come up with chosen primary subject, and then choosing the most downloaded document for that subject. There's other things that I can do once I feature engineer all this other information. So, but yeah, that's what I'm doing.
So assuming you have this other information, how would you combine that, like those features with the collaborative filtering model?
With which one?
With your collaborative filtering model.
So it'll be an ensemble model, right? So there'll just be a number of questions and decisions as you go along. Where do you fall? Are you a cold start problem or not? With the collaborative filtering, they really can't do anything per se with it because there's no activity. It'll simply just be a number of decisions as you go along, which recommended you go to. That's essentially what it is. Sorry.
So I used to run an engineering council recommendations.
Okay.
Congratulations, you basically just built the 2005 council recommendation.
Oh.
Yes.
All right. Yeah.
So one of the biggest problems that everyone likes Harry Potter, anyone Harry Potter is a good enough recommendation. Which I think might go to a little bit of the first time on this question. Harry Potter is a good enough recommendation for basically everyone. It's not serendipitous recommendations. Have you thought about serendipity? Have you thought about Harry Potter?
That's a good question. Yeah, you're right. It's like how do you actually tailor it to give them what that is not just the most popular thing. This is the next step. I would like I said, I have a lot of information on these people, a lot. It's just very hard to actually just engineer at this point. And there's a number of things that I can do with that, but so it's just that's the next step. Essentially, just harnessing what they're doing, who they are, and the trends especially. Just this is why I wanted to look at time. Do some people stay within trends or they move along? And if they stay within trends, then actually you can start directing them to certain other things that they not have seen. Like Harry Potter example, that's a very trendy thing. It's like people just go along with it. And that's a way to sort of circumvent that. Do you see certain users that don't follow that? Well, then you can actually start directing them. So, yeah.
Good afternoon, everybody. My name is Pranati Sahu. I collaborated with a company called Mobisrit to optimize inbound calls for their search advertising. Mobisrit helps companies to acquire new customers by doing call targeting using search advertising and social media marketing. Basically, whenever someone clicks on their ad, they pay money for the click. And whenever that someone meets advertisers' criteria, spends sufficient amount of time on the call, they make money. So they wanted to optimize their user funnel in order to get more qualified callers so that they can generate more revenue out of it. For this project, I received 2 years worth of data of 68 different campaigns for one particular vertical, and the data consisted search information, keywords, and search terms, also call details and click informations. The data was pre-processed because they run campaigns based on advertisers' requirement for the locations and the time. So I lost a little bit of signal because of that, but doing EDA really helped understand what factors influences the conversion rate. This particular plot compares the click-through rate to the conversion rate, and the size of the bubble indicates that the cost for conversion. So the right bottom part of the chart, these campaigns, I found out that has a really high click-through rate, which is more than 80%. However, the conversion rates are really low, which basically indicates the callers are churning very quickly. So it could be due to a poor quality of the IVR, which is the interaction voice response that company designed to navigate the caller to the right agent, or it could be over-promising on the ads itself, not delivering on the ad. So probably doing an A/B testing to investigate more on what is going on and what type of IVR options would work better to engage the callers will help keep the callers more engaged in the call and convert them later. I also built a topic model using non-negative metrics factorization for the search terms, these are the topics these are the outputs of the model using the reconstruction error and the topic itself. I decided to use number of topics to be 3, and I put only 5 highly ranked words for each topic, and one of the observation I had is the keywords. Some of the keywords correlates to higher conversion rate, but the same keyword, if it's used with some other keywords, that can correlate to lower conversion rate. For example, in topic 1, the number really correlates to higher conversion rate. However, the same word number correlates to lower conversion rate in topic 3, which is 23%. So doing A/B testing on the keywords, various keywords, and what keywords really converts better, really help understand where to focus on to improve the conversion rate, particularly on the search terms which categorizes at topic 3. I've built linear regression model and random forest model in order to predict conversion rate, but the root mean square error was really, really high. So for my future work, I would like to focus on researching on different algorithms which will help improve the accuracy of the model, which can predict the conversion rate better. Also, it will be interesting to analyze the jump frequency of the keywords and really understanding how it impacts the cost per click, the bidding cost. Thank you for your time.
recommended next steps was to run an A/B test, I think maybe on the prior slide. Yeah, and on the slide and on the next. How would you construct an A/B test to answer the question that you're trying to answer with this? And what is the question that you would be trying to answer through running an A/B test?
Sure, that's a good question. So basically, I feel like callers are churning very quickly on this one. So maybe the IVR, which is designed like the option that navigates the caller to stay on the call for longer and really navigate them to the right agent to get the answers. Maybe it's poorly designed. So A/B testing on various options of the IVR will help understand whether that's one of the factors that is causing quick churning. Also, the other thing could be designing the ad, or if the ad is promising too much, make sure that is delivered over the course of the IVR, the call flow. So those are the things I would like to tweak and A/B test on those.
There's a number of different ways that you can present or visualize data. Looking at what's there, with a little bit of, just kind of take yourself out of the presenter role for a few minutes and pretend you're in the front row. Look at that visualization and tell me if you think that's the best way you could have delivered a message to somebody who's maybe not a data scientist, somebody who's more of an executive audience.
Yes, maybe just focusing on these campaigns, having a different graph might help, particularly for people who are not from data science world.
Yeah, there's a number of different ways you can go, so I'm not obviously telling you how to do the next one, but when you look at something that's that busy, you're looking at something that will lose an executive audience.
Right.
So probably for the next one, just choose a different visualization.
Sure. Yeah, thank you.
Hi everyone. My name is Ricky Babel, and I'm looking at how language affects educational outcomes. I partnered with a company called Yup. This is a messenger app that connects students with tutors. They focus on a Socratic teaching method that encourages collaboration between the student and the tutor, rather than just the tutor lecturing. The question I was looking to answer for them is, what are the determinants of student success at Yup, and how can we communicate these to our customer base through a blog post? Their customers are mainly parents and teachers. And as far as the session level goes, it's important to note that we have some categorical variables assigned by users and tutors. Session success is defined as whether the student arrives at the solution themselves. Student rating of the tutor is also included, as well as whether the student can. As far as EDA went, it was really important because I was able to add value quickly through descriptive analytics. I'm going to focus on what pertains to the model I've actually built. We can see here that session counts were highly right skewed. 2/3 of students only completed 1 or 2 sessions. This lack of long-term usership suggests that there could be some disconnect between the tutor's methodology and the student's needs. My model is going to look at if we can measure if tutor messages contribute to this gap. In terms of the model I selected, I went with a mixed effects logistic regression. The important thing about this model is that it accounts for dependencies within the session level data. We have students that have completed multiple sessions, meaning that the data is dependent on this level. It's also highly interpretable, much like a traditional logistic regression. For my final model, I looked at just successful sessions, and how tutor-based factors affected student satisfaction. Student satisfaction was defined as whether the student complained at the end of the successful session or not. In order to find the features that were significant, I used a likelihood ratio test, in order to find my results. And here they are. The duration of the session was negatively correlated with student satisfaction. This intuitively makes sense because students obviously don't want to spend too much time in their homework. The phrase "good job" was positively correlated with student satisfaction. This is interesting because you can see the phrases on the right have no effect on student satisfaction. And there's similar positive sentiments that suggest some difference between good job and, say, nice effort. Almost there, and the word yet were negatively correlated with student satisfaction. Because it goes against traditional educational theory that suggests that these words will encourage students to persevere and succeed at the problem at hand. How I would interpret this is that these might help for short-term goals, but if the student is dissatisfied at the end of the session, it's ultimately not a long-term sustainable language to use for the tutor. In terms of future work, I'd love to look at how language interacts between different subjects and how that affects learning, and also looking at sentiment analysis within the tutoring session as it goes on. I'd like to thank Yup in particular for being so cooperative through the process, and you guys for being such a great audience.
So it almost feels like the terms that were negative correlated are, so it almost feels like the Socratic method is negative correlated with student satisfaction.
Yeah.
So how would you tell that to a company that whose whole product is based on a Socratic method?
I think that's an important point. And my findings aren't suggesting that it's completely making the student dissatisfied, that there's a balance in that we can see that a tutor just saying, you're almost there, keep going in your same direction. There has to be a compromise that the tutor might need to cut off the student's persistence, because I think these results speak to there's some atrophy in the student's learning process.
Again, also, why are you optimizing for student satisfaction instead of just student learning, for example?
Sure. Well, the important thing to note about the student success metric is it's defined by the tutor. So looking at that metric as a target variable and using tutor-based factors, there's just inherently going to be leakage there. So that's why I chose to focus on what was satisfying to a student in this learning environment.
I had a similar question, so maybe you'll follow up on that a little bit more. I was curious about how you selected the, and it sounds like you just said that for each individual session or module, the tutor sets expectations essentially that are the success metrics. Is that right? So that's why you wanted to.
Yes, basically the expectation is the student will come to the solution themselves or they won't. And yes, it depends on what kind of problem the student brings to the table. And that's why I use the mixed effects model that controlled for that student dependent variation.
Do you think that there might be, I was just curious thinking about this, like, for example, if the outcome variables are on student satisfaction, some
students who are sort of like naturally dissatisfied, maybe some sort of like bias in terms of who would rate themselves as satisfied or dissatisfied and how that might impact your results?
Yeah, and I think that goes back to using a mixed effects model too, to control for some of that variation in like a student satisfaction threshold. But I think that is a good point. That's something to look into.
So just real quick, as a follow-up, you said that what you discovered here with the terms contradicted some existing research that's out there?
Yeah, Carol Dweck has a popular philosophy called the growth mindset as it relates to education, and a lot of that's basically kind of the status quo in education and kind of what Yup built itself around. But Yup is also interested in adapting with that, and also having a blog post promotes Yup. If a blog post becomes popular in those circles of, here's something that suggests something this different about the status quo, that's how I'm adding value here.
Well, no, I'm more wondering about, you found contradictory results to existing research, right? So you can't both be right, can you? Or is this a case where you've got something environmental?
Yeah, that's a good observation. And research, it's obviously a different environment to how an educator might research this in a room with a student rather than over text. And they're different environments, and yeah, it's going to lead to different outcomes. That's why it's kind of interesting to just say that there's not that many environments like this.
I think one thing, just to follow up on that, one thing that might be implicated here is possibly the time scale of the nature of the student satisfaction, right? Yeah. I mean, so, from the growth mindset perspective, right, this is sort of about actually inducing an increased, sort of acceptance of struggling against problems. So first of all, a lot of students don't necessarily want to struggle more when they're already in a tutoring situation. And second of all, maybe the positive outcome of the learning isn't necessarily measured within this session, right? So it's very possible that there's positive long-term knock-on effects, but what we're actually measuring here is them sort of rebelling against the fact that they, didn't get help in the form of an answer instead of getting help in the form of coaching at a process level. And as a teenager who struggled through plenty of school myself, I mean, that's what pissed me off. So it seems plausible.
Yeah, I think that's interesting, and that, like, is there a way to stop some of that frustration and subtly introduce these kind of growth mindset opportunities, right?
Right. I think that's the question.
Yeah, and that's what I was trying to get at, but we're obviously in very early stages here.
What did your data set actually look like? What were the features and what was the predicted variable?
In terms of the predicted variable was my target, that was student satisfaction, which was measured on whether the student complained at the end of that session.
So that's like a binary variable?
Yes, that's a binary variable because it's a logistic regression. And then the duration was in minutes. And this was simply Booleans of these encouragement variables. Okay.
Hi everyone, my name is Thomas. And I was very fortunate to be able to partner with a company here at Galvanize called Beamly. So Beamly is a product management tool that connects with other collaborative tools such as Slack, GitHub, and Asana. And it's used to help product managers track the progress of their projects and also predict possible delays. Now this is very important for product managers because this can allow them to take preventative measures to ensure their project is completed on time, which can essentially save them thousands or even millions of dollars in terms of cost overruns and getting their product out to market quicker. So I was tasked with looking through their GitHub pull request comments from various organizations to see if I can possibly predict whether a project will get delayed or not. And if so, can I build a model to automate this process? And then in part 2, if there was a delay that was detected, what amount of time it would take to get it resolved. So here's a brief glimpse of the data I was working with. It's everything you can expect to see in a GitHub pull request, such as the number of lines added, deleted, number of commits. But there is a unique feature there called delay, which the team at Beamly individually reviewed thousands of pull request comments and labeled them whether it actually did delay a project or not. Also added another feature to determine the amount of time it took for the project for the problem to get resolved by subtracting the time the day the comment was created and when it was merged. So here's an overview of my methodology to attacking this issue. First, I would put the comments in an NLP model, which I'll get to explain more later. And from there, if there was a blocker, can I classify it in certain risk level? And in this case, anything greater than a day. So predicting a delay, I started by converting the raw text in a TF-IDF matrix, plugged it into my models, and from there I optimized for my F1 score. The reason being, although I wanted to capture as many product delays as possible, I didn't want to include too many false alarms, because I know product manager's time is very valuable. So for part 2, estimating the risk level, I used the other GitHub features I had, such as the number of lines added and deleted, but I also wanted to find a way to include the text features as well. So I used LDA topic modeling to reduce the amount of dimensions I had to just 12 topic features. I experimented around and found that 12 gave me the best performance. So here are my model results. I was able to predict a delay with pretty high accuracy, 83%, so it's much higher than the baseline, which was just choosing the dominant class. And for estimating the time to resolve the issue, I found that using the LDA topics was able to help me increase my accuracy. So for future directions, I wanted to find a way how I can exclude work hours. For example, if someone pulls in a good GitHub pull request at 5 p.m. and someone's not able to look at it until the following morning, how can I exclude those hours from my results? Also, I wanted to include more risk classes. Right now, I'm just looking if it's taking longer than a day or not, but it'd be great if I can see if it takes longer than a week. And finally, can I assess the type of risk that's involved, or the type of issue, such as is it a typo or something much bigger? So that's all I have for you today. Thank you for your time, and I want to say a special thanks to Beamly for providing me with the data and providing me with amazing support throughout the whole project. Thank you.
Kind of indicated at the end, in that last slide, I think that you were looking at code complexity as a measure.
Yeah.
Don't you think that would be kind of the biggest
correlating
feature to risk? Would be code complexity or complexity of the issue?
Yeah, definitely. It was just a little difficult to find that using the LDA topic modeling, maybe because of the context of all the different pull request comments from different organizations and the way they phrase certain things.
Can you talk about the size of your data set?
Sure. I had over 8,000 different pull requests from various organizations.
Repos? Just one repo, or
how many?
How many repos?
Oh, how many repos? It was over hundreds of repos.
How would you productionize this? So you have this accuracy about you can predict a delay in a product feature. That is what you're trying to predict, isn't it?
Yeah. Don't know if I can disclose that. You can ask the company that's in the audience.
We're right here.
You want to learn more?
Okay.
Oh, yes.
Did you get a sense either qualitatively or quantitatively how much variance there was across organizations?
I actually didn't get the opportunity to look through that, given the short time frame, so I just made a broad generalization about the data.
Even just qualitatively, did you get a sense that things were very different and things were very across organizations?
In terms of
Average time to merge or the
no, I couldn't really tell everything because depending on what the pull request was, that varies the time a lot. So, thank you.
Hello everyone, my name is Sandy, and for my project I worked with the Air Force to optimize aerial refueling. So in its essence, aerial refueling is a vehicle routing problem where every day centers in the Middle East requests for aerial refueling. Each request has a specific aircraft, time that it is requested in, and airspace, and a request amount. And they have at their disposal around 70 refueling aircraft every day that they need to match to a fuel request. At the moment, planning is done all by hand, and their only objective is to pair every request with a refueling aircraft with really no consideration given to efficiency, which is troubling given that the elimination of just one extraneous mission could save $1 million a day in fuel maintenance. So vehicle routing falls generally under the domain of integer programming, which is like linear programming, where you have some objective that you're trying to maximize or minimize subject to a series of constraints. However, with integer programming, you have the additional constraint that each variable has to take on integer form. So for example, for this problem, I modeled nodes as fuel requests, where either they were satisfied or not satisfied, and edges as the traversal of airspaces, where either a refueling aircraft took that path or they didn't. And for my model, I minimized the total number of missions required to satisfy a day's worth of requests. So initially, I set up my model using the open source Pulp library and coin solvers, but those were not performant enough for the volume of data that we had, so I switched over to the Garobi solver, which was able to deal with our data because it takes advantage of things like pre-solve, where it is that are infeasible in the solution space before it even sends it to the solver. It also uses linear relaxation, where it solves the problem as if it were a linear programming problem, and then iteratively enforces the integer constraints. It also takes advantage of local search heuristics to converge to an optimal solution more quickly. So as far as validation for my model, the intent behind this was more of a proof of concept that this problem can be solved in this way, which was successful. So now I'm currently working on implementing it into the classified environment where the data actually is stored and the planning takes place. Once that's finished, I'll be able to validate my model against different efficiency metrics. And in the future, I think it'd be really interesting to be able to recommend models based on different objective functions that better match the landscape of supply and demand for any given day. But until then, I will continue improving on the product that I have right now. So with that, thank you, and happy to answer any questions.
Did you find the global minimum cost solution?
So the data I have available is representative.
Sorry, not global world, but in the solution space.
Sure. So I terminated my program before I actually converged to a solution. The solver allows you to set different stopping conditions, which really isn't a concern for me right now, because the data I have is actually dummified classified data. So it's representative, but not exactly the same. So it didn't make sense to just sit around waiting for something that wasn't actually real data.
I just want to, as an example, call out something that you did that was actually as a presentation tool, very effective. Your problem solution, run a twist on the one twist. That is effective across the board, getting and keeping attention, especially when you throw a dollar value like you did, right into your first couple of seconds. It's very effective.
Thank you. Yes. No, so planning is done 3 days in advance. Thank you.
folks, we are going to be taking a 10-minute intermission. During this time, you can get up and stretch your legs a little bit, and we will be seeing you back right around 3:55. I'm looking back at you, Dan. 3:55? Yes. Let's see what 3:55.
I agree with you.
It started again in 1 minute. So please take your seats. We'll be starting again in about 1 minute. Yeah. All right. So, thank you everyone for being here. We're about to start the second half of our presentations. We have 7 more to go. And without further ado, I'd like to introduce you to Ben Fine.
Hey there, my name is Ben, and I'm going to be talking to you about predicting crop yield today. After finish up Galvanize next week, I'm going to be working with a social venture in Kenya that works on doing credit risk assessment for smallholder farmers. And as part of their modeling, they predict crop yield using satellite imagery. So I thought my final project here at Galvanize would be an awesome opportunity to get a jump start on learning about satellite imagery and crop yield prediction. So I actually use data from the US because there's a lot more data, even though the process that we're going to go through is transferable to doing crop yield prediction in sub-Saharan Africa. So for my problem, the way it's framed is predicting crop yield by county. And this is what the data looks like, zooming in on an area of Kansas. You might look at that and say, is there really anything there that you can use to predict crop yield? Fortunately, the answer is yes. There's been several studies that use this data and get pretty good results. And there's actually 9 different bands. Some of these bands are visible radiance bands, like green, blue, some infrared, and a couple temperature bands as well. So one of the challenges with using this data is that you have variable size inputs. So some of the counties have 30 times larger land area than other counties, and for many models, that's a challenge. Also, for some of the larger counties, you have up to 10 million features over the course of the year, which is very wide data considering we have less than 10,000 rows. So one way you can deal with this is to just take the mean for a given band, like for the green band, for a given county, you can take the mean of all values. But you would end up discarding a lot of information doing this. Instead, I followed the methodology from a paper that was presented earlier this year that looked at the distribution of pixel values for a given band. So for example, if you're looking at the green band for the image on the left there, you can represent the distribution of pixel values as a histogram, and a histogram can equivalently be seen as a heat map in the middle of it. And if you take the heat map that corresponds to the green band values for one county at one point in time, and you look at several points in time over the course of the year, you can stack up those heat maps so you get a 2x2 array that captures both time and the distribution of pixel values. And then you feed these histograms into your model, and you end up with a stack of 9 of these representing all 9 bands. So to start out with, I use a convolutional neural network, following the methodology of the paper. And convolutional neural network makes sense because we're working with images and we want to abstract features out of these and predict crop yield. So for my initial results, I ended up in a similar ballpark as the paper and did slightly worse, and I'll be happy to discuss that in the question and answer session. From there, I was interested in bringing other features into the model. So in particular, the yields from previous years seems like something that has potential for information. And I use this architecture to combine satellite imagery with previous year's yields to do crop yield prediction, and ended up getting significantly better results from this. So to summarize the results, started off with a simple model, got slightly worse results than the paper, and then added the previous year's yields and ended up with slightly better results. Moving forward, there's many things that would be fun to try. One thing that I've started on already is not just looking at satellite data from one year, but using many different years of satellite data and combining that, and using an architecture like this where you're using an LSTM, which is good at dealing with sequences of data. There's also other types of future directions, not just model architecture. One thing I'm really excited about is doing a better job at classifying whether each pixel in the satellite imagery corresponds to crops or not crops. And I also look forward to applying a similar process using histograms, using these kinds of neural net models to predicting crop yield in sub-Saharan Africa. Thanks so much.
You kind of seem like you glossed over one of the biggest problems that data science projects have. You found out enough data in the initial set. Can you talk about, was that really a problem, or did you just switch quickly to US data?
So, in terms of publicly available data sets in Africa, it's extremely limited. Like, I know the company I'm going to be working for, I have a sense of the size of data sets that they have access to, and it's, you know, order of magnitude less than the US, several orders of magnitude less than the US. So their strategies in terms of data acquisition as well as transfer learning to deal with that. But I wanted to first get the model up and running in an environment where I could compare with known benchmarks, and then look at both transfer learning approaches as well as applying the same process to different data.
This is just a question about one of the slides. I might have missed something, but in the slide where you showed how your first and second models compared to the paper, you mentioned that the second model performed had better accuracy. Oh, okay. I couldn't see the y-axis wasn't totally clear, but now I can see what it was. I wasn't sure what the units were for the 5.5, 5.7, 6.5. So that might be helpful to call out in the future when you're doing that presentation.
Did you try out averaging the green band and trying, instead of doing the heat map approach, you just average it out at first, and did you do that?
Yeah, I did do that. I had a baseline model that did that, and also instead of using a neural net, I tried a couple other models like random forest and linear regression, and those were all substantially worse. I took them out of the slide, but they were around 7 or 8 in terms of the squared error.
Hello everyone, my name is Clark, and for my capstone, I have designed a Airbnb review summarizer. So the motivation behind is that even though it's very important to consider reviews for making booking decisions, it's often a very time-consuming task, and more often than not, people just scan through a few and then decide to move on. So I believe having an efficient way to parse reviews and highlight the key aspects from them will not only save time, but also create a bigger, better, more comprehensive picture. So here are my solutions offered in 2 stages. First, to provide a high-level summary of pros and cons around the most frequently mentioned aspects. And one step further, allows the user to filter the aspect and only focus on the aspect they care about. A little bit of a methodology behind 2 major steps: aspect detection as well as opinion mining. So basically, for each sentence in the review, the model will identify a noun phrase in a sentence and as a candidate aspect only if there's a valid opinion expressed on it. And then it will group together similar aspects and then rank them according to the order of frequency. So to quickly demonstrate the use case, let's say for someone who's new to the city and doesn't really know what to expect, the model outputs a list of top aspects for a particular listing, and along with a list of their good and bad. So as an overview, the user can easily spot that for this particular listing, the neighborhood actually raises a red flag here. On the other hand, for somebody who comes in already with a concern in mind, for example, parking, they can simply filter through the list of aspects and then to bring out the insights that are most interesting about without having to go through a long list of reviews you don't really care. So now the question is, how do I validate my model? I use the traditional approach of human tagging, and basically, which is to manually label aspects and sentiment directions for each sentence in the review, for which I create a web app in Flask to streamline the process and to enhance scalability. Given the constraint of time, I was able to manually label 100 reviews consisting of 281 aspects and to use as benchmark for validation. And my model turns out to be 43% accurate in terms of aspect detection. I thought about a couple of reasons that might be preventing it from getting a higher score, which actually leads to my future work. First and foremost, my test set is still a little too small, and I'd like to expand that into a larger set by through more manual labeling. And also, my model is still limited with respect to hidden aspect detections, as well as sentiment analysis in terms of more complex sentence structures. And that's where I'm going to devote more research on in the future. Thank you so much for your time, and I'm Scarp. I do have to answer any questions. Thank you.
So the smaller size of your validation set notwithstanding, sentiment accuracy of 91% is anomalously good. So I wonder, what does the label distribution look like there in terms of if we looked at that as a confusion matrix? You know, are there things that you are having an easier or harder time capturing in the data?
The sentiment score I calculate based on purely based on the aspect that's been successfully determined. So, which is that the 43% of the data already have correct aspect detection. And the model, the measure of sentiment is to calculate the polarity score with respect to the adjective describing that particular aspect. And so using that metric, anything with a positive meaning will demonstrate a score, a positive score versus a negative score, and which shows that which leads to why the sentiment score actually is easier. It's an easy measure calculation. Obviously, there are limitations from the packages I was using. There are terms that do not really demonstrate a positive or negatives in terms of the polarity score, but for example, the word helpful, you should demonstrate a positive meaning, but given the limitation of the technique, it's actually demonstrated 0. So and then I was trying to manually mine some of those obvious, easily appearing terms, and basically putting more conditions for the sentiment analysis.
I'm just curious from a scoring standpoint of the sentiment scoring. Were you doing that at a sentence level, or were you doing that for individual reviews? Like you give the
I'm doing that
score?
for the individual aspect level. So in that sense, that way it matches up with the purpose of projects to actually define the actual aspect particularly. But one specific sentence might have multiple aspects being described in it, and I want to be able to capture.
I understand. Okay.
Thank you, Larry.
Thank you.
Good afternoon. My name is Winston. So for my capstone project, I have a partnership with the company Synthetic Medicine. And the focus of my project is to identify molecular signals for Huntington's disease. So let's first talk about Huntington's. What is Huntington's? Huntington's is a genetic disease that affects patients' brain and body movements. Currently, there is no cure. A major problem in treatment development is that if you already see the outside physical symptoms, then it is too late for treatments. Therefore, in my project, I'm trying to identify the inside molecular signals before the patient expresses any symptoms. So let's take a look at the workflow of my project. The raw data contains 57,000 genes and their expression levels. After taking out genes with low expression levels and genes with low variance, there are 7,000 genes left, which is still a really wide data. Therefore, I reduce the dimensionality by doing a round-up forest and select the top 500 genes. Then I performed a second random forest and ended up with the top 24 genes. So the reason why I chose to use random forest to build my model is for its interpretability. When you pull a single tree out of the forest, it looks like this. So here's the tree. Now it's really easy to visualize what gene our model uses to make each split. If you look at functions of some of the genes, So the first gene, Homo sapiens jostling, is related to motion. This second gene, with the name no one can pronounce, phospha something something synthase 1, is a brain gene. And this third gene, Homo sapiens ubiquitin B, is related to neurodegenerative diseases such as Alzheimer's and Down syndromes. Remember, Huntington's is all about brain and motion. So the fact that the genes our model selected for us makes so much sense to the actual pathology of the disease is absolutely amazing. Absolutely amazing. When I got the top 24 genes, I asked myself, is it just luck? Can I reproduce the results by another approach? Therefore, I built a gradient boosting model with similar workflow and ended up with the top 20 genes. So here are the top 24 genes selected by my random forest model, and here are the top 20 genes selected by my gradient boosting model. In the middle are 3 out of the 50 clusters made by hierarchical clustering on the 7,000 gene dataset. Each cluster contains around 150 genes based on correlation. So at first glance, the two groups of genes look like they have nothing in common. However, if you map them back, you can actually see that many of the genes belong to the same cluster. So even though the two models do not create perfectly identical results, at the broader level, they do support each other's findings. So what we can learn from this figure is that cluster 3, cluster 13, and cluster 19 are the clusters that we would like to focus on when looking for molecular signals. So in conclusion, with this project, interpretation-wise, I identified genes and gene clusters that are related to symptoms expression of Huntington's disease. Prediction-wise, my gradient boosting model can predict whether a patient expresses symptoms or not with 83% accuracy based on 20 genes. And remember, the goal is to identify early-stage patients as treatment targets. So the next step of this project will be to dive deep into functions of each gene and each gene cluster we selected. What molecules do they actually produce? And whether those molecules can serve as good molecular signals to the benefit of treatment development of Huntington's disease. And that is the end of my presentation. Thank you for listening. Questions?
How are the clusters determined? Is it just the method, or is there something you're referencing?
So the cluster was done based on using the 7,000 gene data set, which is the second step here. This one. And then the method I used is hierarchical clustering. But I also did an NMF to make other clusters. But for NMF, somehow it created really unbalanced clusters. So I ended up using hierarchical clustering.
What was the most challenging part of this project?
The most challenging part, I would say, is to try to reduce the dimensionality because there are only so many roles in my data and thousands of genes there. So I have to reduce and reduce and reduce dimensionality in order to build a model. And besides that, I think the presentation part. Yeah. For me.
Examples did you have?
I have 100 rows, 100 patients. So that is why I was only making 50 clusters because the number of clusters are limited by the rows I have. So if I can get more data points, then I think I can further refine this project.
How would you get more data points?
If the company gives me more, then they have more. Yeah.
If the company didn't give you more data.
Yeah, that's the evidence they have for Huntington's disease because they aren't really focusing on this because it's so rare. So, thank you.
So this show first aired in 1964 and has since accumulated a whopping 26,242 categories.
What is Jeopardy?
That is correct. My name is Maya Charkert, and in my project, I analyze Jeopardy question data from 1985 until the present. For those of you who may not be familiar, this is a structure of a Jeopardy board. As you go down the board, the questions get progressively more difficult if contestants get fewer questions right. So I was interested in predicting question value based on the actual text of the question. And there are a couple of reasons why I thought this would be interesting. First, the current process for validation is probably very time-consuming and costly to show. Second, perhaps more interesting, this could be a way to develop methodologies to assess commonality of knowledge of a certain subject area. And this would be very useful for fields such as public health. So the way I approach this is I first apply TF-IDF to extract the words that differentiate each clue the most from the rest of the corpus. I then implemented a co-occurrence calculation to estimate the probability that a given set of words appears together in a question. And finally, I thought that given the broad size of the data, naive Bayes probably perform best in generating predictions. So a little bit more behind the idea of using co-occurrence as a way to get at commonality of a question and thus particular type of knowledge. I noticed when looking at the data that things that appear frequently, for example, Freud, he gives about 50 times as an answer. And when Freud is the answer, words such as psychiatrist and psychoanalysis frequently appear. And those types of questions tend to be easier. On the other hand, things like Vienna and cigar are more marginal and less related, and thus I expected to see that those types of questions would be more difficult. So these are the results. There are 5 evenly distributed classes being predicted on. So by randomly guessing, we would achieve 20% accuracy. My model achieved 0.24, and as expected, naive Bayes outperformed supported machines. From the relevant plot, we can also see that the model has a slightly easier time predicting on questions of easier difficulty. So part of the problem of Jeopardy data set in general is that there's just so much variability in the data, and the 100 most common categories only account for 11% of all questions. For that reason, I also try to reference other corpora, and my idea was to reference Google Ngrams, but the API is very slow, and I could just not get enough data for this type of a large data set. So that would be something to pursue in the future, and could perhaps be very interesting if the Google Ngrams API is being optimized a little bit more. That is all I have for you today. Thank you very much.
So I'm curious about the way that you framed this problem as fundamentally basically a classification problem, saying which of these difficulty brackets does the question fall into? Is that right?
Yes.
So I wonder, alternatively, what if we consider about framing this more as a regression problem, where we have a dollar value associated with each of the questions, ranging from $100 to $1,000, and see if we kind of predict them more on a continuous scale. Is that something that you consider?
That is a great point, and I discussed this with a lot of people. No one had thought of that. I think that would be a very good way to actually get at more of this variability.
Thank you.
Hello everyone, my name is Amir Sheikh, and I've made a board game recommender. So why recommend board games? The problem with board game recommendations today is that there aren't any models being employed in personalizing the recommendations for users. So what ends up happening is the most popular board games like Codenames, Catan, Managrams get recommended to the mass population. And the more advanced user has to spend time discovering games by understanding mechanics, researching more and more about games. So, and it's also a really big market. In 2016 alone, in the US alone, there were $300 million in sales just for board games. So I started by scraping the most popular website for board games there is, boardgamegeek.com. And although they have an API, this bit was challenging because they don't provide a way for anyone to extract all of their user information. So I had to run parallel Selenium scrapers for days to process almost 150 gigabytes of data, extracting 500 million ratings across 5,000 board games. From that, I made my sparse matrix, which, to give you an idea of how sparse it was, if you were to take a 20 by 20 patch out of my matrix, I only have one data point there, and my model is going to be expected to fill out all the remaining ratings. So most people end up rating board games between 6, 7, and 8. And there's a wide distribution of how many board games each user uses. It's very right skewed. You can notice there's some users that rate 500 games. There's some that rate about 1 to 5 to 10. I decided to split my user, or subset my user data into 2 types of users: an active user and a sort of casual user. I decided to split on 5 ratings or less because it neatly divided my data in half. Also, I noticed after modeling with the entire data set and then these subsets that there was good reason to split on this data set. It's good reason to split on 50 ratings. So the framework, I decided to recommend to my 2 different users in a different way. For my light users, I really want to recommend, I want to retain the way it's currently done, which is recommend the more popular games. But for my advanced users, I want to personalize to their current ratings. So I use a different model for each, cosine and Jacquard for my light users, whereas a Pearson similarity for my more advanced users. The results I found are interesting for, let's start with light users. It's interesting that cosine similarity and Jacquard similarity perform relatively similarly to a baseline RMSE, which is just recommend the same thing across the board. The baseline is essentially, since there is no model, if you were to recommend at random across all the board games, you pick the same rate for every single board game, and that's the RMSE you would get. What's interesting about the fact that cosine and Jacquard perform similarly is that it's less important for my light users, the value of the rating itself, as compared to the fact that the rating exists in the first place. This performs well if you're familiar with board games at all. You realize that both similarity metrics pulled out popular games like Pandemic, Carcassonne, Catan, whereas a random pulling out of 5,000 is sort of all over the place, and more complex games are in there as well. So for my heavy users, I decided to use Pearson similarity because it removes the effects of the average rating for that particular game, thereby relying more on the similarity between 2 games. And it did really well compared to my baseline RMSE. And here's a cherry-picked example. For a user Long John Silver, at least 50 games, I know about this person, and I get more of a complex recommendation for 10 recommendations. In the future, what I'd like to do is, after building more of a validation for precision and recall type validation, build a web app that I can provide a portal through BoardGameGeek.com for to deliver these recommendations, get some more feedback, and then perhaps try matrix factorization that would account for not only the item-to-item similarities, but also the user-to-user similarities. Thank you for listening to my presentation. My name is Immersive. Any questions?
I'm just curious about the feedback piece of it. Did you think about changing the, I guess, rubric of the feedback that you were getting? Maybe instead of just a blanket rating, do something else? Do you think that might have changed accuracy or might help you out in any way?
Yeah, so that's a good question. I spent a lot of time thinking about what my baseline metric should be. In the end, of course, I decided to blanket rate the same rating across every game, trying to represent a random recommendation. If I were to try, so the task is predicting a rating for every user item pair in my matrix. For a random recommendation, there really isn't a whole lot better metric I can do. One thing I could do, instead of rating 10 across the board for all games, is rate the average of the entire data set for every single user. All I would do is provide yet another number here, maybe a little bit lower, since my average is now being incorporated into the predicted rating. But the the point of my findings is less to do with how these RMSEs compare with the baseline, perhaps, and more to do with how different models between my heavy user set and light user set perform.
Looking at future work, what if you change what you ask them to rate? Thinking about, in terms of, they're giving you one type of feedback right now, scale from 1 to, whatever.
Right.
What if you asked them how many hours they played? What if you asked them different questions? What if you got different feedback?
Absolutely. In fact, there's a lot that can be done with this data. This, to my knowledge, no one has analyzed this data even to this extent, because it's not publicly available. And there's a lot of other game data that's available, like features like mechanics, dice rolling. In fact, I have a lot of that. And one of the things I tried sort of on the side is a more complex FunkSVD model of my advanced users with side data that had several features, like categorical features for each of the board games, like min-max playing time, min-max players, even a nice description of every single game. But as a first pass, building up from a no model, I think a simple model like this would be a better approach. And then once I receive more of a feedback from this model, I'd love to incorporate something more complex.
I thought that was a really smart thing to segment users into heavy and light. I think you mentioned you picked 50 maybe because it was the median, but I was curious to hear more about that. And one other thought was, I don't know if all of those users have been on the site for the same period of time, but maybe you have people who are newer to the site, but they're still heavy users in terms of how many ratings they provide per week, or if there's some other potentially aspects that you could take into account around determining heavy or light usage.
Absolutely.
And I was wondering if you thought about that as well.
I didn't think about taking into account metrics like how long they've spent on the web. I don't think that is really available in the data set, but there is a lot of other good information about the users, like countries. One of the most interesting things I'd like to get my hands on when I restart the scraping, which takes a very long time, would be users that haven't rated games but have them in their collections. There are a lot more users that I didn't capture. And I could use sort of an implicit model on those people. Yeah. Does that answer your question? I think it might be two-part that I might have missed.
Yeah, I was kind of just generally wondering. I think you said 50 was the median, that was why you chose it, or I don't know if you looked at other percentiles.
So there's two reasons why I chose it. For one, it divided my data in half as far as users go, right? You can see that this is sort of like maybe 50% of my data is really like 42. 42% of my users and then 58% of my users. The other reason is, if you compare the variance of their ratings, this side of users have a much larger variance, and this side has less, which indicates that the heavy users tend to be more critical of games. They rate further away from the average. Whereas a light user typically goes, oh, okay, I'll rate this game at 8, because most people are pretty. Thank you.
Hello everyone, my name is Christopher, and up here on my title slide we have a fun phrase that really captures the idea of my project. It goes, fool me once, shame on you, fool me twice. I actually forgot the rest of it. And that's a shame because my project is all about memory and memory development, particularly looking at spaced repetition. So spaced repetition is a memory development technique that will help you move information from your short-term memory over to your long-term memory. And it will do this by taking advantage of this thing called the forgetting curve, which psychologists found empirically starting like in the 1880s. And the idea is, if you see a piece of information the first time, you're going to forget it pretty readily, pretty quickly. But the second time you see it, you're going to hold on to it for longer, and it's going to take you longer to forget. So the more you see it, the longer you'll remember it without having to reference it again. So traditionally, the question that's been looked at with memory is, will you forget something? And people want to prevent you from forgetting it. But I wanted to take a little twist on that question and instead ask, how well will you remember? So to begin answering this question, I looked at Numasign, which is a space repetition software, and it is a software that lets you make flashcards, and then it'll give you them to you to review every day, and like things you forget more frequently, it'll give you more often. So they have a really rich data set with 10,000 users, 42 million flashcard reviews, 10 years worth of data, and to help us answer the question of how well will you remember, each flashcard review is associated with a grade. 0 to 1 means like you're forgetting it, and it goes all the way up to 5, which means like it's in your back pocket, you just pull it out whenever you want, and that's something like it's in your memory, it's yours. So there's a bunch of user logs that look like this. There's timestamps, which card you should look at, and then like we parsed out for the useful information and creating a model out of it. The baseline we looked at is predicting the most frequent class, which is a 4. You remembered something with minimal effort. That accounts for about 29% of all flashcard reviews. So I created a logistic regression that has an accuracy of about 0.47. And something really interesting I found when I was training the model is I didn't have to look at all of the users I had. I looked at 40% of users, 60% of users, 75% of users, and tested the model against users it hadn't seen, and the accuracy didn't fluctuate too much. That kind of tells me that maybe there's some strong underlying pattern in learning or memory development that is being captured with fewer amount of users. So some of the really cool features I found were first looking at the card grade from your previous reviews. So if it's the 4th time you've seen a card, the grade you got when you saw it the 3rd time is a pretty good predictor of how well you'll do on this current card. Another interesting metric or feature was the user's mean pass grade. So like maybe some people learn faster, and so they just have a higher like mean grade. And so like we use that as a predictor, and also like in our test set, we just use the global mean grade from the training set to fill that in. And another cool predictor was total time seen. So if we go back to the forgetting curve, it flattens out every time like you see something, and that really helps us in our prediction. But an even stronger prediction than just the number of times you've seen it is the number of times you've seen it since you last forgot it. You know, while you're seeing it in the beginning, you might like still be getting it wrong, you had a bad day or something, or like you just have so much other stuff in your head. But the more you see it without forgetting it, that is a really strong predictor of like how well you will remember it. And in the future, like there's a really rich data set that I have available here. So looking at things like the effect of cramming, the time of day, habit forming, are there more effective ways of developing your memory? Like I think there's a lot of really cool things you can find here. And if I didn't forget anything, that's the end of my presentation. Thank you very much. Do we have any questions?
Yeah, this was very interesting. Teachers benefit from your project?
So this is an interesting question because we're dealing with specifically memory, so you have to have seen something first rather than learning, like you're just creating it out of nothing. So like I want to make that distinction first. So how teachers can benefit from this, so these are some of the things that like were most predicted in my model. And so like being able, so there are certain kinds of information that benefit really well from like seeing it more than once. Like that's why this is used, spatial repetition is used in like learning language, learning history, or so on. So like any kinds of those factual things we would want to look at. And maybe teachers, like if they're using this kind of information, they can instead like try to like break it up into small digestible chunks and just try to show those repeatedly, you know, and then like they can track their students, like are they remembering it, are they forgetting it, and get kind of a handle on how well they've learned it and how well it's in their memory. And then like if they see that their class or any student isn't forgetting something for a while, they can be pretty comfortable about that student having retained and learned that piece of information.
Hi everyone, my name is Wei. I did my project in collaboration with a company that handles home loans. That's the title. So there are two major parts of what the company does. First, they convert a customer from a sales lead to having their loan application locked. And second, they process the loan until the customer gets the money. So my contribution to part one is to simply predict whether there will be a conversion. So the company can identify best customers and focus on them. And for the second part, I'll try to predict the timeline that they need to process the loan so the company can use it as a marketing tool. The data set we have has about 10,000 cases of loan applications and about 420 features. Each of the features corresponding to a field that the customer fill in on the loan application. And I actually spent a few days had to clean and process the data before I actually could feed into the model, which includes some dumpification of categorical data, vectorization of text data, and some manipulation of daytime features. So let's go to part one. As you can see here, the lead conversion is actually a 6-stage sales funnel. Customers, but more information from each of them as we move along the stages. I built 6 different models for these 6 stages. Out of the 10,000 cases, only about 4 to 5% actually converted at the end. So I had to perform random oversampling to deal with the imbalanced classes and to fit the data into our predictive model of a random forest classifier. So before I did the project, the company actually had 2 metrics that measure the customer's potential, as they call lead score and intent score. And my model, here on the third one, managed to outperform both of these models in terms of accuracy, F1 score, and precision. Another useful output from the model is the feature importances, which allow us to identify for each stage the top factors that contribute most to the conversion probability. And based on those features, we can construct a profile of an ideal customer so the company can focus on with the future marketing. That highlights, for example, the age, the income, the borrower, and the whole purchase cost. Now part 2. So this is a number we're trying to predict, namely the number of days that the company needs to process the loan from locked to funded. As you can see, it can range from 5 days to 150, which is about 5 months. Unfortunately, despite the different algorithms and models we tried, including this you can see here, and plugging in almost all the features we have on our data set, we didn't manage to find a log signal. But we did observe some interesting pattern over time. Over the history of the company, as you see, in the beginning, as the company was scaling and getting more loans, that they couldn't really handle, the processing time increased. And in 2016, they actually have a period of heavy understaffing, and the processing time was really long. But by 2017, the company implemented a major change on the website, which largely reduced the processing time and improved the efficiency. So in conclusion, for part 1, we built a multi-stage model which has a high predictive power, but also high interpretability. For part 2, we didn't find a log signal, but we did observe some interesting pattern at the time. So some future work may include implementing both of these predictive models into the workflow of the company, and try to improve part 2 by including some external features or some complex algorithms. That's the end of my presentation. Thank you. Any questions?
I was wondering if you could tell me a little bit more about your methodology for your model evaluation. Were you evaluating against a held out evaluation set, or are these cross-validation numbers, or what?
Yes, for especially part 1, I did held out a test data set. I tried both ways. So because of the nature of the business, I held out the latest loan cases to be the test set. And also in the second try, I randomly selected about 30–40% of the cases to as a test set. So we actually have the labels for those test sets and also stratify the test set. So I have some for both positive and negative cases. That's how I got the test scores, and I performed the models, my model and the benchmark models on the same test sets, the training test sets.
Awesome.
Any more? Thank you.
So that concludes the G42 Capstone presentations. I want to spend a moment to thank all of you for coming here. We have one more round of applause for our panelists. And although the presentations are done, by all means, you can continue to grill our students into the wee hours of the night. So if you want to follow up on any presentation that you saw, any more questions you might have, just want to have a conversation, they'll all be available. We're going to have a happy hour in this very room. So there will be, at some point, drinks and food that will show up, or it's already showing up. Then, by all means, talk to our students, talk to our panelists, come talk to me if you're interested. If you are a prospective student, this is what we could be doing in another 12 weeks. That's pretty cool. So thank you everyone again, and let's have some drinks.
Thank you guys again. Thanks for having me. I did try these other models. I just didn't talk about them at the time. Yeah, it's really interesting, especially in the last year. It's just, you can kind of tell that it works in street. It's full of area. Cut that out. It's not part of my presentation.
When we're thinking about data science, you have to learn how to write good data science. You've got really cool sentences sometimes to get somebody's interest. And the three sentences do not start off with, okay, hang on, let me just take this step and that's how it's done.
You mentioned this, like, get in you mentioned particularly, and I completely agree for the student to be refueling in their course. Awesome, very well sort of presented, motivated, clear, like how, and like, yes, You'll be available in 3 years.
She was published in an article. The Huffington Post wrote about this project. She was working hard.
He's already snapped up crop yield predictions. And really, and what he did is because he found them. It's like, okay, represent this histogram in each of the images. Replicated that, and then ran further with it. And that even right back. And like, dude, you can even say that whole architecture slide that he showed for future work. He built it. It's currently running. He's just waiting for results. So like, but yeah, I'll also argue that very proud of
We're all like working because you had stupid questions and everything. So.
Yeah, how was it? Did that, from your point of view, is it how strenuous was analyzing? There were we've tried to do that where like, okay, so we have 2 minutes. Don't think something you know they're going to have to ask me about because you don't have time for 3 minutes. So I can work some things. Most possible quantitative results. I think you're at 3 I didn't explain it. It's a good strategy also because there's an defensive component. There's also how you control the questions that you might see on your presentation, the things that you're prepared to still based on the people. Like, oh, absolutely everything else. But then you run the risk of like your head with the super cool architecture. Like you said, oh, tell me more about that architecture you want to do. You could have actually said, actually, it's running right now. But like nobody knew to ask that. Like I'm not going to sit back and as this instructor be like, hey, tell us about the thing.